So we have been given BST, and we have to insert 2. So as insertion goes simply as in BST, we just add 2 where it belongs, that is as the right child of 1. Now we splay for 2, left and right, this becomes a zigzag condition. 2 goes to the top, and this is the result. Now again we splay for 2, and this is a zig-zag left situation. 4 becomes the root, 2 becomes the root, and 1 becomes the left node, and this is the final tree after insertion of 4. So now we are going to do find and delete minimum element. So finding the minimum element is easy. We keep going left until we just can't, and this is the minimum element, and then we perform as it is left. This is a zigzag condition, so we perform the zig, and then we get 1 comes to the top, 2 becomes its right child, 7 becomes 2's right child, this and like this. So this is after, and then this is just 1 plus 1 down, so we do a simple zig operation, and one becomes the root, 2 comes here, and this whole subtree comes with it. 9 becomes its right. 9 becomes its right child, and 2 becomes left child of 9, and q becomes its right child, and then comes here. This is due to the single zig operation, and then after finding min we delete 3. So we replace 3 by the next node here, and we remove 1, we replace 1 by the next node here, and 1 is gone, and this becomes the resulting tree. Then here we can see it is left and right, that is zigzag, so we perform zigzag, and 3 comes here, 2 becomes its left child, 4 becomes its right child, and then again right and left, this is again a zigzag. 3 comes to the top, and 1 becomes its left child, 6 becomes its right child, and this goes here, and this goes here. So 3 is to the top, and then we are going to remove 3 by copying its successor, which is 4, to the root. And so we put the value 4, we shift the value 4 here, for example, and then we do deletion operation here like this, and this value is big, this value is 4. So this is the resulting tree. We have deleted successor and removed the node and reattached the single child.